Okay, let's do a couple of examples of solving right triangles. Here's two triangles. Let's take them one at a time here. I've got a 15-degree angle in here. I've got a hypotenuse of 4. And of course I know it's a right angle here. Well, if you know two angles, you certainly could get the other angle if we wanted. I could calculate that angle B here. Well, one thing we know is that in a right triangle, these two angles are complementary, so angle B has got to be 90 degrees minus 15 degrees, which is 75 degrees. Okay, so that's easy enough calculation. Where we start using trig is when we start looking for these side lengths. So let's focus on finding side length A here. That's opposite side A. The side that I know is the hypotenuse. So when I look at that, known angle 15, side I'm looking for A, side known 4. This angle, those two sides, this angle, those two sides, that would be either the sine or the cosecant. Now, since I'm going to use my calculator to do this, I'm going to stick with one of the three trig functions that the calculator knows, so I'm going to use sine. So what I know is that the sine of angle 15 degrees is equal to the opposite divided by the hypotenuse, A divided by 4. Well, I can do some algebra here. I'm looking for A, so multiply both sides by 4. 4 times the sine of 15 degrees is equal to A. Well, there we go. What's A? A is equal to, and I'm going to use my calculator. All right, I'll slide my calculator over here. Get that out of the way. Put the calculator in. Turn it on. There's all my calculations from the last time. I've got 4 times the sine of 15 degrees. Right? My calculator is in degree mode, so it assumes that this is degrees. So 4 times the sine of 15 is 1.035. It's whatever. Okay. So I'm going to write this down here. 1.035. Okay. Now I could, now that I know side A, I could use Pythagoras to find side B. I could say 4 squared minus whatever this number is squared. However, I'm not going to do that because I want to point out that I could use trig. When I'm looking at this now, 15-degree angle, the side I want is the adjacent side, and the side I know is the hypotenuse. Adjacent and hypotenuse, that angle, that's a cosine. So I'm going to look at the cosine now of 15 degrees. That's got to be B over 4. Multiplying both sides by 4, I've got that B is equal to 4 times the cosine of 15 degrees. And so now we'll type that into my calculator. Oops, I almost got off the page there. Slide this back over to my calculator. Get that out of the way. Here we go. This is now 4 times the cosine of 15 degrees, which is 3.86, more or less. I'm rounding on each one of these. Now, one of the reasons why I chose to do it this way and not use Pythagoras is because I did round on this solution. I did round it to 3 decimal places. If I then use that to calculate the other side, I'll be using a wrong answer to try to get the next one. When I come back to this point right here, the 4 was given, the 15 was given. The only thing I don't know in this equation is the one I'm looking for, B. So I don't mind it if you round when you give an answer, but if you round and then use that answer for something else, that's when you're going to start seeing larger and larger mistakes. Those errors will compound as you start working with rounded numbers. I mean, sometimes it's unavoidable, but if you can't avoid it, let's do that. Okay. So there's that angle. I got a quick double check that I can do because I know that in any triangle, the smallest side should be across from the smallest angle, and the biggest side should be across from the biggest angle. I think you might be able to figure out then that means that the middle side should be across from the middle angle. So with my angles here being 15, 75, and 90, 15 is the smallest angle, and so side A should be the smallest side. 1.035, 3.86, and 4. Well, good. That's the smallest one. The 3.86 is smaller than 4, so 4 is the biggest one across from that 90-degree angle. So that gives me some indication that this is at least a plausible solution. The small angle across from the small side, the middle angle across from the middle side, and the big angle across from the big side. Okay. Now let's come down here, take a look at this one. Here I've got a 37 degrees. It wouldn't be too hard to figure out that other angle, whatever that would be. 90 minus 37 is 53 degrees. So that would be that angle if you really needed to know it. But let's work with the 37 degree angle here. And let's find side y. Okay. Well, 37 is known, 9 is known, that's the adjacent side, and y is the one I'm looking for. So the opposite side is what I'm looking for, the adjacent side is known. Those two sides, that angle, we're talking either the tangent or the cotangent. Again, my calculator does tangent, it doesn't do cotangent. So I'm going to work with the tangent here of 37 degrees is equal to y divided by 9. Multiplying both sides by 9, I got that y is equal to 9 times the tangent of 37 degrees. So I can type that into my calculator. I'm not going to slide it over to show you, but I'm typing in 9 times the tangent of 37. My calculator is still in radian mode. And if I can get this typed in right, there we go. It tells me that y is equal to 6.78 and some change. Just quickly checking, that was a 53 degree angle across from the 9. This is the 37 degree angle across from this. So this is the shorter side across from the smaller angle. That's good. Lastly, I want to find z. Again, I could, if I want, now use Pythagoras. I've got 9, I've got 6.78. I could square them both, add them up. But I'd be using this rounded number. I don't want to do that. Let's go back and use the trig. I've got 37 degrees. I've got 9 being the known side, that's the adjacent side, and the hypotenuse that I'm looking for is the unknown side. Adjacent and hypotenuse, that's either the cosine or the secant. Again, my calculator only does cosine. So let's take a look at the cosine of 37 degrees. That should be the adjacent over the hypotenuse, so 9 over z, not 9 over 7, 9 over z. What I need to do is solve for z. Now this is a little bit trickier, not too much more tricky, but with the variable you're looking for in the numerator, it's really easy just to do that. Now I've got to do a couple things. So first I'm going to multiply both sides by z, so it cancels out on that side, and I end up with z times the cosine of 37 degrees equals 9. And then divide by this to get the z by itself. So z equals 9 divided by the cosine of 37 degrees. So there we go. I type that into my calculator. 9 divided by cosine 37. And it tells me 11.27. All right. Now, some of you might have, well, let me show you one. Some of you might have done this. Rather than that, they might have said, well, I like the z on the top better. So maybe you did do this one as the secant of 37 degrees equals z over 9. That's a z on the top, z over 9. So multiplying both sides by 9, you get that z is 9 times the secant of 37 degrees. But how do you calculate the secant of 37 degrees on your calculator? Well, you're going to divide by the cosine. I mean, that's equal to 9 divided by the cosine of 37 degrees, which is the calculation I did anyway. Okay? So think of it either way. Do it as cosine or do it as secant, but solve for the side that you're looking for. Okay? There you go, solving right triangles.